Howdy, this is Dr. Nandi. I'm back again with part 3 of the integral calculus word problem. So I'll share my screen with you. So part 3, problem. An object is dropped from a height of 400 feet. If the air resistance is proportional to the square of the velocity, then dv by dt is equal to minus 32 plus kv square, where 32 feet per second square is the acceleration due to gravity and k is a constant. So we are still working on part A, which is to show velocity vt is equal to minus square root of 32 divided by k tan hyperbolic inside parenthesis square root of 32k and then t. Okay, so far we have derived that square root of 32 plus square root of k times v divided by square root of 32 minus square root of k times v is equal to natural number raised to the power of minus 2 square root of 32kt. Okay, so we will now multiply both sides by square root of 32 minus square root of kv. So on the left hand side of the equal to sign, we have square root of 32 plus square root of kv is equal to natural number raised to the power of minus 2 square root of 32t whole thing multiplied by square root of 32 minus square root of kv. So the left hand side of the equal to sign stays same, and we are going to distribute the natural number raised to the power of minus 2 square root of 32 kt to first to square root of 32, that is we multiply with natural number raised to the power of minus 2 32 kt minus natural number raised to the power of 2 minus 2 square root of 32 kt times square root of k times v. Okay, now we are going to move all the v terms to the left hand side of the equal to sign. So we have square root of k times v plus natural number raised to the power of minus 2 square root of 32 k times t multiplied by square root of k and then v is equal to, on the right hand side of the equal to sign, we have e or the natural number raised to the power of minus 2 square root of 32k times t multiplied by square root of 32 minus square root of 32. So from the right hand side, we can take square root of 32 common, and we will have e or natural number raised to the power of minus 2 square root of 32 kt minus 1. On the left hand side of the equation, we can take v is equal, take v the common factor outside the parenthesis, we'll be left with square root of k plus square root of k times natural number raised to the power of minus 2 square root of 32 kt. Okay, so basically we are solving for v, so we will divide both sides by square root of k plus square root of k times natural number raised to the power of minus 2 square root of 32 kt. Okay, so and if we take square root of k in the left hand side outside the parenthesis, on the left hand side of the equal to sign, we have square root of k times 1 plus e natural number raised to the power of minus 2 square root of 32 kt. So that's what you have in the final expression for v. So v is equal to square root of 32 divided by square root of k, and then in the numerator we have natural number raised to the power of minus 2 square root of 32 kt minus 1. In the denominator you have natural number raised to the power of minus 2 square root of 32 kt plus 1. Okay, now we will multiply the numerator and denominator by the same terms, which is e square root or natural number raised to the power of 32 kt divided by natural number, same number, square root of 32 kt, or same expression. Now we will distribute the term, extra term that we multiplied in the numerator and denominator to the terms inside the parenthesis. When we do that, we get v is equal to square root of 32k, and there is a, yeah, there is a, and if we take the minus 1 outside also, we get e square root of 32kt minus e square root of 32kt. Okay. Divided by, in the denominator, we have e square root of 32 kt plus e square root of 32 kt. Now, the definition of tan hyperbolic x is e to the power of x, natural number raised to the power of x, minus natural number raised to the power of minus x, divided by natural number raised to the power of x minus so there is slight bit of mistake in the sense that the first term is the next second term in both of these numerator and denominator should be e minus square root of 32 kt. So actually it should be in the numerator inside the parenthesis e square root of 32 kt minus e minus square root of 32 kt. And in the denominator it will be e square root of 32 kt plus e minus square root of 32 kt will be the exponent. So then we can fit it into the definition of tan hyperbolic x, which is e to the power of x minus e to the power of minus x divided by e to the power of x plus e to the power of minus x. Hence, v is equal to minus 32. Remember that minus sign which was hanging outside in the numerator, in the outside the parenthesis, that comes out, and we have minus 32 square root of 32 over square root of k tan hyperbolic square root of 32 kt, which is same as minus square root of 32 by k tan hyperbolic square root of 32 kt. That was what we were supposed to show for the velocity. Now in part B asks what happens to velocity when t approaches infinity. Okay, so limit t approaches infinity, inside the parenthesis we have okay minus 32 square root, should be a minus sign, square root of 32 k tan hyperbolic square root of 32 kt. Okay, now when t approaches infinity, okay, what happens? The tan hyperbolic becomes a minus 1. So minus with a minus, there should be a minus in front of square root of 32k, which I missed. Okay, and when t approaches infinity, tan hyperbolic square root of 32kt approaches minus 1. So minus 1 times the minus 1 in front of square root of 32k gives you positive 1. So it is square root of 32 over k equal times 1. So when t approaches infinity, the velocity approaches square root of 32 divided by k. That's the end of it. If you have any question or any comment, please do not hesitate to write to me. I'll get back to you as soon as possible. Thanks for watching. I appreciate it, and please subscribe to my channel by hitting the red subscribe button at the bottom right corner. Okay, I'll see you next time with another problem and another solution. See you. Have a nice day.